This is how you can learn and practice the Go programming language. Golang is quickly becoming one of my absolute favorite programming languages, and it's awesome because you can do so much with it, and it is cross-platform. Runs on both Windows, Linux, Mac, wherever you need it to be, and it is super fast and powerful. You can do so much concurrency, so much with coroutines or Go routines, and honestly, there are tons of great resources online to learn all about it and get started. One of them that I want to introduce to you today is called Gophercises. It's on Gophercises.com, and it is a free course, not so much a course, but really a set of exercises and projects so that you have something to do. You have something to play with and explore, and you have something that you can try your hand at putting together code and building something without scratching your head and trying to think of, okay, what's a new project or what's something that I can do to keep playing and learning something new. And that is where Gophercises comes in, and let's get to play with it. Before we dive into the video, here is a quick note from today's sponsor. Cybersecurity is ultimately everyone's responsibility. The onus is on both you and me, and we have to take it seriously to protect critical infrastructure and the technology that our whole industry is built on. The growing cyber attacks on critical infrastructure severely affect government and the common people. And one common thing between the Colonial Pipeline, Ukraine's power grid hack, and others is the absence of skilled professionals. So we need proven tooling and training to step up to the plate, and that is where OPSWAT Academy can help. OPSWAT Academy offers critical infrastructure, cybersecurity training and certification for free. You can learn operational technology and industrial control system cybersecurity, the Purdue model, malware concepts, and other topics all online for free. With OPSWAT Academy, you gain access to tons of courses to teach you how you can prevent against modern threats, reinforce your own learning with self-evaluations, and master the craft. After passing the exam, you'll gain a verifiable certificate. If you're looking for new opportunities, certifications and credentials from the OPSWAT Academy can prove to potential employers that you already have the skills to protect vital assets and critical infrastructure. If you're looking to upskill your own team and keep your organization secure, or you're looking for professional growth, check out OPSWAT Academy. You can jump in with my link in the video description and start to improve the way you protect critical infrastructure. Huge thanks to OPSWAT Academy for sponsoring this video. I am online at Gophercises.com, and you can see it is free coding exercises for budding gophers, the mascot of the Golang programming language, and all you need to be able to sign up is just entering your email address. It is of course free, but hey, you need to provide a working email address so you have an account, and he promises I won't spam you. This is created by another individual. It is an online resource all around and being geared towards having something to do to learn a new language and getting a chance to play and practice. There's a lot of really good learning here. It showcases everything that is included, all that it's going to be discussing, and all the things that you might end up learning. And there are some of the exercises listed below. You can see a whole lot of these, some super cool stuff like a quiz game just to get started, URL shortener, building out things for parsing HTML links, creating a sitemap builder, phone number normalizer, command line task manager, etc., renaming, so much stuff. Really great resource here. So I am going to go ahead and create an account. I'll enter my email address, sign up. And there is a note here, Gophercises has been migrated to this website to make things easier for the maintainer, and there's emailing a license key, so that should be sent to my email address. I'll go get that. And if you read on in that email, he does explain that this will add you to his email list. This is all put together by John Calhoun, a cool fella who again puts together a lot of these great free hands-on exercises to be able to play with Golang. So I don't have any issue with that, but of course you can unsubscribe as needed. All of this showcases the overview for the task that you have when you're looking at a new exercise or project, and then you have including the solutions and some videos that explain how you could go about this. So if we go ahead and click into this first one here, we do have the overview where it explains what this is, about a 3-minute video, and I'm going to check this out super quick. Ultimately, they end up referencing a GitHub repository that explains what this is, including a lot of other examples that other students have completed. Going through those student examples, that way you can learn from others and get a chance to read code, not only write code, and then see other ways to approach the problem. So for this first task, we need to create a program that will read in a CSV file, or a comma-separated value file, and create a quiz. It'll keep track of how many questions the user gets right and how many they get wrong. and then move on to display the next question. The file name is going to be default problems.csv. However, you should be able to customize that with some command line arguments, and it'll all be in the format described here. At the end, the quiz should go ahead and output the total number of questions that the user answered correctly and how many questions there were to begin with. Anything that is an invalid answer or incorrect can also be displayed here. They explain here that the comma-separated value files or CSV files might have commas just inside of the very first field, and that's when they're using quotes in this as well. So it's worthwhile to use the CSV package or library in Golang and not try to write your own CSV parser. This challenge is split up into two different parts. I think for the video's sake, I'll only get into part 1, but part 2 is going to go ahead and play with setting up a timer, so there is a time limit for submitting an answer. If you have any interest, of course, you're welcome to go play with this. That's why I want to showcase it, and of course, the solutions that they offer will cover that just as well. Okay, so I'm going to jump into my terminal and see if I can go ahead and start on this challenge just as well. I do have Go already installed. It is a command that I can go ahead and run. You'll notice I do have the output to be able to work with it here. Go is a tool for managing Go source code, and I have a directory for my Go stuff inside of my user profile here. So just for the sake of being able to work with things in a smart and sane way, I'm going to go ahead and move into the source directory, and I'll go ahead and make a directory for Gophercises, and then I'll go ahead and move into that directory. Oh, I jumped into Golang. Let's move into Gophercises, and now let's make it another directory for the quiz game. There we go. Jump into that. And now I do want to go ahead and initialize this as a Go module, or kind of a package or library, or really the program that I want to end up working in. So I'm going to use the command go mod init, and that will go ahead and create a little go.mod file. Now, if you want to check that out, we can go ahead and open it within Sublime Text, and that is what we can see here. It is just going to be within Gophercises quiz game and the version of Go that I'm using. Now, if you want to go ahead and go mod tidy, you certainly can. Kind of good practice, but there's nothing to really work with right now. We should go ahead and create our own CMD directory, so we have commands inside of that package that we want to end up working with. Now I'll go ahead and make a quiz_game.go. And that way I have a file that I could work with here for the quiz game. Perfect. Now that opens up, and this should be our main package. So I'll go ahead and type that out, package main, and that is how you declare or define the package or library or module, however you kind of want to interpret it, of what you'll end up running or using within Golang. Now, the main package is what we'll end up executing as kind of, hey, the actual beginning of the program or what we want to execute, and we can go ahead and start with a main function. You'll define func to declare a function, and then you'll use the name of the function, in this case main, so that it is automatically the thing that is ran or executed when you invoke this. I don't know if folks tend to know, but there is actually a default print function. So if you just wanted your own super quick, super simple hello world program and application, you could go ahead and then println, all lowercase here, not using the format package that we'll get to in a moment, but this will go ahead and display that onto standard output. We could go back to our terminal and then use go run to go ahead and start our quiz game. All it's doing is a simple hello world, but if you wanted to just as well use go build, that will go ahead and actually build out inside of this package name, really the directory here, our cmd.exe. If you don't like that name, we can go ahead and remove cmd.exe. I am in PowerShell, so rm is going to be an alias for delete or del. And we could just go build quiz game. Now passing that as an argument, we should see quizgame.exe. And I could go ahead and / to run quizgame.exe, and there's our hello world output. That's all fine and dandy, but we want to go ahead and actually get command line arguments, and that is where they were suggesting using the flag library. You can import a library or a package with just that syntax import, and then a string, so wrapped in quotes, around the name of what you want to import. Flag is going to be a natural, like standard library for Golang, so we could work with it. But if I were to try and go ahead and compile or run this right away, I'll go run quiz game. Oh, and let me actually remove the executable because I just want to use the source code packed to and passed to go run. With that, it will whine and yell at me, oh, this module was imported but not used because we haven't done anything else in our source code to really work with it. So let's go back to our web browser and look up how we might be able to go ahead and work with the Golang flag package or library. There is some documentation for us available at package.pkg.go.dev. And I'll zoom in here. This is how we might be able to work with command line arguments or flags. We'll go ahead and import flag as we've just done, and then create variables or vars based off of flag values that we might be able to retrieve. This example is using an integer flag for a number. However, we want a string to be able to use that problems.csv or CSV file. And then ultimately you'll run flag.parse to be able to retrieve all those. Ultimately, we want to end up using that string variable. However, this was defining integer flags. So let's go ahead and scroll down to look and see what other functions might be available to us within this package. And we could see, oh, there is maybe a potential string value that we could use. Let's go check out what that does. And the string function might take a name being a string type, a value being a string type, and then a usage string type. And it will return the address or pointer to a string. String defines a string flag with a specified name, default value, and usage string. The return value is the address of a string variable that stores the value of the flag. Okay, so let's go play with that. I want to be able to use a flag.string based off of our CSV file name, I suppose is a name, or just CSV file. The default value we know is problems.csv, and then the usage that we want as kind of the help description can be the file name of the CSV file containing quiz questions. Does that work? I think so. Let me go ahead and add some new lines in here so that's a little bit easier to read. Okay, so that ultimately ends up returning a pointer to our CSV file name, correct? So that should be a variable that we want to declare, but we need to specify a type for it in Golang. You could use like, the var syntax to be able to define that and know that it's going to be a pointer to a string. And then theoretically, that should be able to run for us. But we could also just, without needing to declare the type, we can just use that walrus operator or add a colon right in front of the equal sign to let Golang automatically figure out and know what that type should be. Ultimately, we could go ahead and work with this. We could try and print line of our CSV file name, just like that. Let's go back to our terminal, try and run this. And we get just a memory address, right? 0x hex value something, because that is a pointer. We need to be able to get the value out of it, and that is why we will end up referencing it with the ampersand. Because remember, this is a pointer, right? CSV file name is a pointer of a string value. Now, if I were to use that without the walrus operator and then just let that be defined, let me run that one more time. Still getting a hex value. Let me go back to using this with the walrus operator. Let it figure that out. Still hex value. We need to return that as the pointer, correct? There it is. So we can use that asterisk to retrieve the value that we're hoping for there. But again, if we just wanted to actually go ahead and specify our own new CSV file, how about .csv or whatever, that will not run for us because remember we have to pass it as a flag. So if I actually use tac help, see if it'll tell me. No. Tac h. Nope. Don't forget, we need to actually use flag.parse. Now it should try and look through these for me. So if I do that one more time, let me go run quizgame.go. Without any arguments, it tells me problems.csv. But if I pass that tac h, now we have the usage to be displayed here for us because we are in fact using that flag.parse to try and receive these. So tac help would return that just as well. But note, if we pass in our CSV file, now I could use my new CSV file.csv value, and that should be retrieved as the value of that variable. So now that we've retrieved the file name that we want to be able to open, we need to go ahead and actually open it. And we can do that with another import, another Golang built-in for us, part of the standard library for packages, and that is the OS package. You'll notice I've separated out the imports by using parentheses and the new strings on new lines here. That's kind of a quick and easy way without having to type import all this and import another one, import all over, etc., etc. So that works well for us. And now I'll have access to that OS package. So we want to now be able to open up that CSV file name. So we could specify a file pointer or filp or file, whatever you particularly want, and an error. Because when we use our walrus operator to run the os.open function, we'll end up passing in our CSV file name, but Golang needs us to actually check if our errors have been set, if this failed or not. So we'll need to check with an if statement, just simply asking if error does not equal to nil. So this error that could possibly have happened if something were wrong. In that case, we need to open up a new logic branch or a little code block here where we need to handle that potential error. Something went wrong. Maybe it couldn't find the file didn't exist. Whatever the case may be, we should do something about it. And we can probably just safely close the program and exit. We could throw a fatal error. So the way we could actually reference that is using another library called log, and that has one that we're able to go ahead and work with. Log.fatal is a find function when we want to actually say a message, hey, something went wrong, but okay, there's an error that we should display here, and then close the program and exit because there was a fatal issue. You could actually use fatal F, I believe, to format this. And inside of the string quotes you pass as an argument here, you could say error opening CSV file, and then %s. That being a format specifier, and we can pass another argument in here for our error. Correct? Let's try it. Let's go ahead and see if we can work with this. Let me go ahead and go back to my terminal. Let's go ahead and build, let's just go run our quizgame.go. Looks like I have a file declared but not used. Okay, that's because I'm not doing anything with this value. In that case, we don't need to store it for the moment, at least for the sake of our practice and playground. Let me change that to an underscore. So it is a throwaway variable. I'm not going to do anything with it right now. It's not actually going to store that and put it into memory. So that way Golang won't complain when it tries to compile the code here. Let's go run this. And there's an error. Hey, error opening CSV file. Open problem CSV, the system cannot find the file specified. Perfect, that's because it doesn't exist. Let's go ahead and see if we can grab that CSV file. Let me go back to Gophercises.com. If I scroll way down here, there is a quiz game module, and then I can go ahead and open that within GitHub. If I click into this, you can get the exercise details and source code just on Git, and this has a sample problems.csv file that we can store and work with. I'll bring that back to Sublime Text and save this as problems.csv. Now that that has been saved, let's try and run this again. There is no error. Our code runs just fine. However, if I were to pass in CSV file for does not exist.csv, we'll get an error. And we're handling that appropriately with our log fatal F that gives me a little timestamp and then explaining the problem. Now let's go back to actually reading this with a file value, and we'll want to actually parse through this as a CSV file. There is another library called encoding/CSV, and this will end up letting us work with that file. Being a CSV file, we could use something like a CSV reader being a new variable declared with our walrus operator using the CSV package new reader function. Then we'll go ahead and pass in that file. But before we cruise onward with that, we need to be super duper cognizant and be sure that we actually close our file. This is something you kind of want to do at the end of your function. However, it's good to do it right after you've gone ahead and opened it. However, we could use of a Golang utility here, nice little keyword called defer. We'll defer closing the file and cleaning up the mess that we made until once the program is finished executing or this function is done. Because we could probably do this all in one function. It'll happen, hey, just as we end the program. Or once we read everything, we can consider this done and then close it manually, but that is a nice trick so we don't have to worry about cleaning up after ourselves. Golang will handle that for us as long as we be sure to call defer file.close. Now, once we read this CSV reader, we can go ahead and work with the data. Well, we can get the data and check if there are any errors by using that csvreader.readAll. We'll check if we have any errors with that same little trick. If the error is not equal to nil, we'll go ahead and check with a log fatal F, error reading CSV. Get a nice little display out there in case there is an issue. Hopefully we don't have that problem. But now we have data loaded into a variable, and we could start to loop through it, go through line by line. Here's one problem in question, here's one problem in question, etc., etc. Let's try and do that. We'll do that with a for loop within Golang. And fors actually have an interesting syntax. They require the definition of two variables when you're saying, hey, I want like the index or the count that I'm on and the actual value, while I loop through a range of data. Range is the keyword here, and you're using the colon, again, walrus operator to inherit all those variable values without needing to worry about their types as we loop through that. And honestly, we don't need to really keep track of the index because that's just going to be, line 0 or line 1 or 2 or 3 or 4. So let's just see, can I go ahead and determine what that value is? And let's change that index to an underscore again, a throwaway value we don't need to worry about, but we still need to be capturing. Let's try and run this. Here we go. We don't have our doesnotexist.csv file, but we do, of course, have our problems.csv for the default, and it's going to return an interesting hex value again. So more memory that we're accessing. Notice it's 2 out of 2. Looks like there are 2 pieces to this. If I were to try and actually index what is at the 0 index of this, is that something that will be displayed here? Let me try it out. Ooh, that gives me the unique problem that we would have read out of our CSV file. If I switch this to a 1, that is actually going to be our answers, correct? All split and separated by our comma separated value. That's what that CSV package is doing for us, nice and easy. So we could basically say, let's check and set the question to be the value 0, and the answer can be value 1, correct? Part of me wonders if we can do this in just one line. I used control / on my keyboard there to comment those out. Golang comments are the 2 /, or if you want a multi-line comment, you can use the / and an asterisk for the star here, and then close that out with an asterisk and /. Now, that question and the answer could theoretically be pulled out of that value, could they not? Let me actually go ahead and add a new import, probably one that you might be familiar with if you're picking up the Golang. It is fmt for format, because we can then use fmt.printf so that we can format and again add new variables to be displayed within what we're trying to display. So we can say question : and then answer can be our answer, with the %s to denote a string. I don't know what's happening. Turn off caps lock. Okay. Now we just apply those as arguments, of course, so we'll give it question and answer, and let's see if it's able to retrieve those values just like that. Go run. Assignment mismatch, 2 variables but 1 value on line 35, so I suppose that's not working for us. We could extract these in some other way, or we could make them a struct, but we don't need to do that right now for the purpose of this very starting video here. If we just declare them separately, now we'll have all these. Notice I'm forgetting a new line, so all of this is just being spat out into one line. Let's be sure to include our \n, which is the escape character, the escape sequence for a new line. If I run that one more time, there we go. Now we have all our questions and answers. Okay, so now that we've read all this in and we've got it being displayed, we could just basically ask the questions here. We could say, hey, let's use question and then display the actual question, not passing in the answer, but this time requesting the answer with something like format.scanLn, scan line, right? And that will need to take in a variable that we want to be able to retrieve and store the user input in. So that means that we need to declare a variable for it to be able to work with. Let's say, hey, var, I guess, input. Is that going to work just fine for me? That should be a string, and then we'll end up putting the data into the address of string. So we'll use that with an ampersand there, being the literal value should be popped into it. Let's see if that will give us anything. Let's try that. Let's go ahead and afterwards say you answered with a little input here, our input, correct? Let's see if that is displayed for us. Oh, answer declared but not used. Okay, yep. Let's do a little underscore there to nerf that out. No new variables. It doesn't really like that, so let's just go ahead and comment that out for the sake of our testing. Question is 5 plus 5. We can say, please subscribe. Subscribe. You answered, please subscribe. Okay, so it looks like it's doing weird things with our spaces, but at least for the purposes of this example, we don't need to worry about it because ultimately we're supposed to be entering just one answer here. What is 1 plus 1? You answered 2. 8 plus 3, etc. So we can start to test these now. Let's check if we actually have valid answers. Let's say if our input is equal to the answer, then we can say format printf, or just print line in this case, correct. And then otherwise, with an else statement, we can do format print line incorrect. And then we'll keep looping and we'll ask for that question here. Now we need to actually have that answer value within scope here because we are going to be testing against it. And checking if is equal to, we're using those two equal signs here so we know that that is actually going to be comparing those two, not assigning. Let's try that. Question 5 plus 5, let's say 10. Correct. 7 plus 3, let's say 10. 1 plus 1, let's get this wrong, let's say 5. That is incorrect. And then 8 plus 3, 11, 3, etc. Okay, awesome. So what we can do here is actually start to count the number of correct answers. So ultimately we need to define a new variable before we start to loop through this and say our correct answers can be 0 to start with, right? We don't need to use a type here because we can again use our walrus operator. And in the case, in the condition that we answer correctly, we can say, hey, our correct answers, that should be incremented plus equals 1, or just plus plus, right? Because we're incrementing that new answer. And then once we're done looping through this, we need to be able to print out all the correct questions and the number of questions that there were actually answered. So let's do that. Let's do format.printf. All done. You answered. And then %d to use a digit or a decimal. Questions correctly. And actually, we can just use all of this in one here so we can get the number that we had correct and the number of questions that there were in total. So that should be nice and easy for us. I'll add a comma here so we can say our correct answers number. That is what we named that variable, correct? Yep. And the length of all the data. Since, again, we're looping through all these questions that were present in that problems.csv file, however long that array is or that list of data, that is the number of questions that there were to begin with. So let's try it. Let me go ahead and run this, and I'll just spam through all of these by hitting enter, and it says all done. You answered 0 out of 13 questions correctly because nothing incremented to be correct. However, if I were to do this properly, let's get 10, let's get 10, let's get 2, 14, yep, 4, 5, 6, 5, 6, 6, 7. I can do math. All right, you answered 13 out of 13 questions correctly. Super slick. So that's kind of it. It's pretty small. Like we did nothing fancy here. We weren't using any structs. We weren't doing any magic. We were just kind of building a little bit of the baseline and getting used to working with Golang modules and figuring out the error handling structure and style, going ahead and using some of these for loops and inputs and reading. And that's all that we needed here. That is at least getting the syntax used to playing within Golang. And if you had any interest, you could explore some of the other example student answers over on GitHub. You can go see what other folks have done. This actually gives you some of their example CSV files again and their quiz code, and you can see what else they might have done here. Probably a little bit of a better structure, not just winging it, and actually using the part 2 portion where they're using a timeout here. So there's a lot that they're playing with. But it's very, very cool and actually good to see some comments in here. And in case this helps you learn something new or see other examples of Golang code, this is how you could do it. Check out what Bart is up to. He's got a main.go. Here they're using structs to be able to answer these, so we can play with those in a later video. But ultimately, that is it. And that is what I wanted to show you, Gophercises, as one new resource, as one other activity, one other playground and tool to help you in your own learning if you're experimenting with Golang and just, catching the wind here and learning the ropes, doing everything you can for a new language that you're trying to learn. This has been a long video and I'm tired of recording, so thanks so much for watching, everyone. I hope you enjoyed. Do all those YouTube algorithm things, like, comment, subscribe, etc. You know the drill. Huge thanks for the video sponsor. Can't do this without them. Super appreciate all their support in the channel and everything that we're up to here. So please show them some love with the link in the video description. And thank you again and again for tuning in. See you in the next video.